Hi everyone! Today we're going to look at the first lesson for our next chapter, which is chapter 12, sequences. So for the first lesson, we're just going to identify sequences. So what I want you to do, there's a warm-up here for you. It's a little bit on the longer side, but we're asking you to find the missing term. So what I want everyone to do is to take a look at these 10 different sequences and see if you can think about what kind of pattern is happening and if you can continue the pattern and then fill in that missing term. So pause the video, okay, take a couple of minutes to try to work each one out and then unpause the video and we'll go over it. Okay, so hopefully at this point you've given each of these a try. And now let's take a look. So if we take a look at this first sequence, we're going from 5 to 9 to 13 and then 21 to 25. It appears as though, let me zoom in here, we are adding by 4. So to get from term to term, I can see that the pattern is if you add 4 to 5, you get 9. If you add 4 to 9, you get 13. And if you add 4 to 21, you get 25. So if I add 4 to 13, I'm going to get 17. So that's the missing term for that sequence. Now let's look at the second sequence. Now you might have thought, okay, I just added, so let me think about adding. So if I added 5 here, I would get 10. But if I add 5 again, do I get 20? No. So let's think a little bit differently about this one. There is a pattern, it's just not adding. So how else can I get from 5 to 10? I could multiply by 2. So then if I multiply by 2 again, does that get me from 10 to 20? It does. And then 20 to 40, it does. And then 40 times 2 would be 80. And then to make sure that we did this right, yes, 80 times 2 would be 160. So the missing term there is 80 and the pattern is multiplying by 2. Okay, let's look here. Now we have some fractions. So if you wanted to not even look at the fractions at first, you could look at the whole numbers, but there must be some kind of pattern going on here. So we could think maybe it's add, maybe it's multiply. So if it was add, to get from 1 to 4, you'd be adding 3. But let's just think about that. If you add 3 to 1/4, would you get 1? Or if you add 3 to 1/16, would you get 1/4? No. So we're not adding. So let's think about multiplying. So 1 times 4 is 4. So let's go back. Does that work here? Is 1/4 times 4 1? Yes, it is. And what about 1/16 times 4? This one, definitely use your calculator. Type that in and you are going to get 1/4. So now let's continue the pattern. 4 times 4 is 16. And then let's make sure it gets me to 64. If you do 16 times 64, you are going to, 16 times 4, you are going to get 64. Okay. Moving on. Now I have 1, then 3, then 5. So I could multiply by 3, since we've been doing a lot of multiplying, to get from 1 to 3, but 3 times 3 is not 5. So maybe let's think back to adding. 1 plus 2 is 3. 3 plus 2 is 5, which means 5 plus 2 is 7. And then 7 plus 2 is 9. So the missing term there is 7, and we were adding 2. Okay, now I'm going from 3 to 33. So I could be adding 30, but then 33 plus 30 is not going to get me to 363. So let's think multiply. 3 times 11 is 33. So now everyone try 33 times 11 in your calculator. I don't expect you to be able to do that just on the top of your head. Off the top of your head, that's going to get you 363. So this pattern is multiply by 11. So now let's take 363 and times it by 11. And you should get 3,993. And then just to confirm that this pattern continues correctly, if you multiply that by 11, you do get 43,923. Okay, now let's look at F. Now this one's interesting because it's going down. But let's look at it. 7, to get from 7 to 4, I could add a -3. Then to get from 4 to 1, I could also add -3. Or you could just think of it as subtracting 3. So then if I keep doing that, subtract 3 or add -3, I would get -2. And then if I kept going, add another -3 to that, I would get -5. And then another -3 to -5, I would get -8. So I'm focusing on adding, and you'll see why in a moment. But if you had written here subtract 3, that's completely fine. You'll understand in a little bit when we get to the next page why I was really saying add. But the pattern is going down, but we're not multiplying. We're now subtracting or adding a negative. Okay, let's take a look at G. So now we're going from -5 to 0. So you could always multiply by 0 to get 0, but then the problem is then every other number would be 0 after that, and it's not. We're going from 0 to 5. So it looks like we can't be multiplying, so maybe we're adding. So -5 plus +5 would get me to 0, and then 0 plus 5 would get me to 5. So 5 plus 5 would get me to 10, which would then another plus 5 would get me to 15. So that works. And over here, 53, then I'm going to 50, then I'm going to 47. So again, this one's going down similar to F, and it actually looks like it might be the same as F. We are subtracting 3. So for this one, let's just think of it as that. Subtract 3, subtract 3. If I keep subtracting 3, I would get 44. Subtract 3 again, I would get 41. Awesome. Okay. 5 to 10, it could be multiplied by 2, or it could be add 5. Well, if I'm going from 5 to 10, I can't be multiplying by 2 if I'm going then from 10 to 15, because then that 15 would have to be 20 if we were multiplying. So we must just continuing to add 5. So then if I add 5 to 15, I'm going to get 20. And then if I kept adding 5, I would get 25 and then 30. Okay, and then our last pattern. So I have 192. Then I have 96, then I have 48, then I have 12, then I have 6, and I have a missing term between 48 and 12. So as far as adding, I'm not adding anything. I'm not getting bigger. And that means also if I'm multiplying by something, I must be multiplying by something that's smaller than 1, because these numbers are not getting bigger, they're getting smaller. So I'm going to first just give everyone an idea. If you took 96 and you subtracted 192, that would tell you what number the difference is between these numbers, and it's -96. So that means I subtracted 96 to get from 192 to 96. Now, if I did 96 minus 96, I'm not going to get 48, I'm going to get 0. So because that's not 0, this must not be adding. So now I don't want to think about subtracting these numbers. Let's think about dividing these numbers. Because if I came back to one of the ones where I where I multiplied, let's go back here to part E. When I first looked at E, I thought, oh, maybe it's add 30, because I was really in my head thinking 30 is the difference between 3 and 33. So I could be adding 30 to get to 33. But because that pattern didn't continue, this wasn't 63, I knew this didn't work. So then, if I'm thinking multiply, now I knew kind of off the top of my head that 3 times 11 was 33, but if I didn't know that, I could have done 33 divided by 3 to get that 11, or 363 divided by 33 would also get me 11. So when you want to know if this number is a multiply number or an add number, you can either divide or subtract to find that value. So it really wasn't necessary until this part. So what I'm going to do right now is I'm going to divide, because it wasn't, we're not adding that -96 because that pattern doesn't continue. So let's take 96 and divide it by 192 and see what we get. And what you should be getting is 1/2 or 0.5. If you take 48 and you divide it by 96, you should also get 1/2 or 0.5. So what's happening here is I'm multiplying by a number less than 1, which is why we're going down and not up with our values. And then you can kind of confirm it here. 12 times 0.5 or 1/2 is 6. So now we just need to find the missing value. So what is 48 times 0.5? And that's going to give me 24. And then 24 times 0.5 is going to give me 12. So that pattern works. So this one was a multiply by 0.5. Okay, so let's just zoom out here a bit. I think I lost my 5 over here. Okay. So we identified the missing terms here, and we found that we had a bunch of different patterns. Some of them were adding by a positive, some of them we could have thought of as subtracting or adding a negative, and some of them were multiply by a number bigger than 1, or in this one case for J, multiply by something less than 1 because the numbers were going down. But these are all different patterns, and then we're going to start calling patterns with numbers sequences. So this unit, there's going to be some new notation that we're going to want to look at. And that notation is called sequence notation. So a sequence is really just a function. So we've studied functions before, right? So functions have inputs and outputs. The input to a sequence is actually the domain, just like it would be with a function. But what a sequence input is based on is the position that the term is. So as I'm describing these definitions, I want you guys to kind of look down here because I'm going to talk about the sequence down here. So look at this sequence below. And if you see, it's going from 4, then to 8, then to 12, then to 16. So the pattern here is add 4. Right? You can keep adding 4 and you're going to get from one term to the next. So 4, 8, 12, 16, 20, 24, 28, and 32. These are the numbers that are in the sequence. So we could think of 4, this is the first term in the sequence, 8 is the second term, 12 is the third term, and so on. 16 is the fourth term. So when we say the first term or the second term or the third term, that's the input of our sequence. That's the term's place in line. Okay, so that would be just the numbers 1, 2, 3, and 4. That's what's going in our domain. Now the term itself, the element in the sequence, the 4, the 8, the 12, the 16, that's the output. So that's actually like our range. Those are the numbers that are actually in our sequence, the numbers in the list. So the notation can be a little tricky. So now I want to focus on that a bit. So when we refer to a term in a sequence, oftentimes we use the lowercase letter a, and then we put a number right here, and we call that number a subscript. And that subscript is going to be the position of the term. So since 4 is the first term in the sequence, we call 4 a sub 1. Just like a sub 2 is 8, because 8 is the second term in the sequence. And a sub 3 is 12, a sub 4 is 16. The little subscript number is just telling you what position that term is along the way. So let's look at this. If part A is asking me to find a sub 3 would be 12, since 12 is the third term in the sequence. For part B, we're being asked to take A1, and we already know A1 is 4, and A7, so let's look for the 7th term, so that's 28, and we're being asked to add them. So 4 plus 28 is 32. Now they want me to take the 5th term. Now the 5th term is 20, and subtract the 4th term, and the 4th term is 16. And that difference will give me 4. And then for this one, they want me to actually find n. So n is the subscript. So that's the number that's telling me what position the term is. So they're really saying what number term is 28. So when I look at 28, I see that it is the 7th term. So n is 7. Okay. So we have different types of sequences we're going to study this year, and there are 2 main types. And if we think back to the warm-up, there were really 2 different types of patterns we saw. We saw patterns that were formed by adding, and we saw patterns that were formed by multiplying. So we're going to give them names. So a sequence that is formed when you're adding or subtracting, really, because when we said subtracting, we also said that could have been adding a negative. But when we're adding or subtracting the same value over and over again, we're going to call that an arithmetic sequence. And the number when you add, so let me just take the example we were just looking at. So 4, 8, 12, 16, 20, let's say that was my sequence. The number that we call that same value that we're adding over and over and over again to get this pattern, that's called the common difference. And in this chapter, we're going to use a lowercase d for that value. Now, we call it the common difference because let's say you wanted to try to find it and you weren't sure. Like when I look at the sequence, I can kind of see, oh, I'm adding 4 to get to 8, and then I'm adding another 4 to get to 12. But if I wasn't sure, you can always take consecutive terms, let's say the second term, and subtract the first term. So if I took 8 and subtracted 4, I would get 4. As long as they're consecutive, this will get you the common difference. So let's say I wanted to take the third term and subtract the second term from it. 12 minus 8 is 4. So that's how you go about finding a common difference if you're looking at an arithmetic sequence. Okay. Now, the second type of sequence we looked at was geometric. Now, a geometric sequence is a sequence formed by multiplying. And now in that last example, we had said you could multiply by 0.5 or divide by 2 or multiply by 1/2. So if it's multiplying or dividing, but it's the same number over and over, that's what we're going to call a geometric sequence. So geometric is the name we give for the multiply sequences. So let me just go back to one of the ones we were multiplying on. I think the first one we had was like 5, 10, 20, 40, 80. So we were multiplying by the number 2. So this number 2 has a name, and we're going to call it the common ratio. And in this chapter, we're going to use a lowercase r for the common ratio. And the way that you would find that, we kind of already went over this when we looked at part J with the number we weren't really sure. How are we getting from 192 to 96 and 96 to 48? We couldn't really just see it, so we divided. So let's go back here. If I wanted to find the common ratio, similar to when I want to find the common difference, instead of subtracting consecutive terms, I'm going to divide them. So if I took the second term, which is 10, and divided it by the first, which is 5, I'm going to get 2. I could do the same thing with another set of consecutive terms. If I took the third term and divided it by the second term, I'm going to get 20 divided by 10, which is 2. Now, because that number is going to come out the same each time, we're taking a ratio or dividing our terms. That's why we call it the common ratio, and that's what we have when we have a geometric sequence. Now, there are definitely patterns that can be formed where we see something happening that we recognize, but it's not adding and it's not multiplying. So an example I would say is, imagine I took terms and I was, let's say, squaring them. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. I could keep this pattern going. It's a pattern, but if you notice, this pattern is not formed by adding 3 over and over. It's also not formed by multiplying by 4 over and over. It's being formed by squaring the position of the term. So if there's any other method being used besides addition or multiplication, it just means that it is a pattern, but it's neither arithmetic nor geometric. And in this course, we're really just focusing on arithmetic and geometric. But you could be asked to identify if something is arithmetic or geometric, or if it is neither. So that's what you're going to practice right now. So if you take a look at the next page in your notes, it says to identify each sequence below as arithmetic, geometric, or neither. What I want you to do is you're just going to write down an A if it's arithmetic, and if you think it's arithmetic, then you're going to list the common difference. So I'm going to do this first one with you. If I looked at this pattern, I can see here that it looks like I'm not adding by 2, right? 1 plus 2 is 3, but 3 plus 2 is not 6, so it's not arithmetic. Now, if I thought geometric, 1 times 3 is 3, but 3 times 3 is not 6, so it's not geometric. So if there's no R and no D, no common ratio, no common difference, you're just going to write neither. Let's try one more. So when I look at this sequence, I see 40 plus 3 gets me to 43. And then I am continuing to add 3. So this pattern is formed by the addition of 3. So that's the common difference because this is an arithmetic sequence. So I'm going to stop here because this is going to be the rest of what you're working on today. You're going to finish this practice. You're going to check your answers to this on Canvas. And the only other thing I would say that might help before you try that, if we came back to the warm-up here, let's just add in our warm-up an A or a G. So sequence A is arithmetic because we're adding 4. Sequence B is geometric because we're multiplying by 2. Sequence C is geometric because we're multiplying by 4. Sequence D is arithmetic because we're adding 2. Sequence E is geometric because we're multiplying by 11. Sequence F is arithmetic because we're adding a -3. Sequence G is also arithmetic. Now we're adding a +5. Sequence H is arithmetic. We're adding -3. Sequence I is arithmetic. We're adding 5. And sequence J is geometric. We're multiplying by 0.5 or 1/2 or dividing by 2. So if you remember now going back, there was not a pattern in the warm-up that wasn't formed through addition or multiplying. So every single pattern here would have been arithmetic or geometric. I hope this video was helpful to kind of get you starting to feel comfortable with this new notation, with these terms, arithmetic and geometric, and all I want you to, again, to do is complete this. You're not going to complete the homework tonight. You're just going to finish watching this video and just finish this one sheet of paper. Please submit all the pages of notes to us on Canvas. So you should have 1, 2, 3, 4 pages being submitted to us and just showing us that you followed along with the video and you completed the last page.